Welcome back, everybody. Here we are today. Today we are talking all about chemistry. And why are we talking about chemistry? Well, chemistry is going to be an incredibly important unit for us to talk about, especially within the biology world, because chemistry is what really determines all of the matter that we then go and talk about when we talk about biology. So when we want to talk about cells or talk about the process of photosynthesis, there's a lot of chemistry in the background of it. So I want to make sure that we are all on the same page with chemistry. So, without further ado, let me shoot on down to my little lower corner here and let you guys kind of follow along as I go through these notes. All right, here we are. So, today we're going to talk about why is chemistry important in biology. Again, I kind of already mentioned that, but again, biology is the study of biological organisms, and biological organisms are made of matter, and chemistry is really the study of matter. Now, as we talk about biological organisms developing, advancing, surviving, their metabolism, all of those basic processes, we're really talking about chemical processes in the background that are really making those things happen. We are going to delve into those big chemical processes throughout the course of the year. So I want to make sure that we are aware of the real basic terminology associated with it, and an understanding that we are all on the same page. The good news is for many of you, this is going to be a review of your IS class. The IS, the Integrated Science Curriculum, does a really good job of covering the basics of chemistry, which will allow us to build on that. So we don't have to worry about too much, new content. Just really just refreshing ourselves, kind of like what we did with the scientific method. You've heard of the scientific method before, but now what we're really doing is we're just building on that. So without further ado, let's get into talking about chemistry. Well, remember, when you talk about chemistry, we're really talking about atoms. And why do we talk about atoms? Well, atoms are incredibly small. If we talk about, um, sorry. If we talk about cells, cells we know are microscopic. Well, cells are made of trillions of atoms. So atoms are even smaller than cells. So we're talking the smallest possible scale here. And the thing is, we can't actually see atoms. We can't. They're just way too small. They're submicroscopic. And yes, we can use like an electron microscope and get an idea of the mapping of large, like metal atoms, but for the most part, like a carbon atom, we've never been able to see. So we have to go off the behaviors as to their structure. Next year, when you guys take chemistry, you will build on this knowledge. You will really learn all about the advanced detailing associated with atoms and how they all interact and they reform and make different compounds and how those compounds interact. So it actually is a lot of fun to learn chemistry, but it's really important for us right now to at least get a foundation so that we can learn biology. So first thing we want to talk about, when we talk about atoms, all matter is made of atoms and all life is made of matter, and so therefore all life is made of atoms. That's why it's incredibly important for us to talk about it. Like we're going to talk about like your cells and the cell membrane that makes up your cells. Well, that's made of predominantly carbon, hydrogen, and oxygen. And then if we want to talk about like nucleic acids, which are incredibly important for making you look the way you look, well, that's carbon, hydrogen, oxygen, nitrogen, phosphorus. So all of these different things are going to be incredibly important just for even the smallest scale molecules that are really important for your body. When you eat food and you get energy from the food, it's really coming from the atoms, the bonds between the atoms, and the way the electrons are shared. So when you actually eat, you're breaking those bonds and gaining that energy. So that's why certain foods like sugars and fats are going to have a lot more energy in them than proteins. Let's go through the structure of an atom. Now, when we talk about an atom, there's three major parts. And what we refer to these as the subatomic particles. Now, what does subatomic mean? Sub means smaller. So smaller than an atom particles. That makes sense, hopefully, to you. These are the things that combine together to form an atom. Think about it like subhuman parts, maybe like your kidney, your liver, and your arm, your brain, all those things. Like singularly, they're not a human, but they combine together to form a human. So what we're really talking about here is the things that combine together to form an atom. And there are three major subatomic particles. There are protons, electrons, and neutrons. Those are our three subatomic particles. Protons have a positive charge to them. They have this electromagnetic charge to them, so they exert this positive charge. Neutrons are neutral or have a null charge, a zero. They don't have a positive charge. They don't have a negative charge. They're just right in that middle. And then electrons have a negative charge. Electrons, if you compared an electron to the size of a proton, electrons are incredibly small. They are very, very small. And so as they are buzzing around, whipping around the nucleus of an atom, they have an immense amount of speed, but their charge is equal to the proton charge. So I know there's a lot of advanced stuff we could talk about, but I'm really just trying to get the simplest version. So you have protons, neutrons, and electrons. Protons being positive, neutrons being neutral, electrons being negative. Right? Now, let's talk about where can we find these subatomic particles. The past so many slides have had images talking all about it. The next slide has an image to identify this. There are two major locations for subatomic particles to be found: what we call the nucleus of an atom, not to be confused with the nucleus of a cell. A big difference. The nucleus of a cell is the equivalent of like a million atoms or more. It's massive compared to the nucleus of an atom. All right. So the center of a cell is made up of many, many different atoms. So the nucleus of a cell is much more complex than the nucleus of an atom. I know this term is going to confuse some of you. So the nucleus of an atom is just the very center of that atom. And at the very center of the atom, you are going to find the protons and the neutrons of the atom. And then whipping around and orbiting the nucleus, or what we refer to as the electron cloud, or orbitals, or valence, or different electron levels and different things like that. Sometimes you hear it referred to as a valence shell. The outermost electron level is called the valence shell. But those are where you're going to find the electrons. They're buzzing around the nucleus. So you have the nucleus at the center, and then whipping around the outside is where you are going to find the electrons. Now, we kind of do these really simplified drawings. Let me kind of draw on here as I go through with you. But here again is the nucleus right smack in the center. Now, buzzing around, these little red dots whipping around the outside, they're moving constantly. So they're making all these different orbitals as they go around the nucleus, right? Kind of like the planets going around the sun, right? But at a much, much faster rate of speed. And what's happening is that even distribution of electrons around the outside kind of equals out the positive charge of the nucleus. So the overall, an atom has a charge of zero. So an atom will have a neutral charge, but it can eventually gain or lose some electrons, which will cause it to be charged. And we're going to talk about that right now. When you hear the term atom, I want you to kind of think of the idea of an element. So usually when we refer to atoms, we're referring to a single element. Now, each element has a different number of protons. That's incredibly important. This, if you haven't really been paying attention to the previous, 9 minutes of this talk, this is the part I want you to focus in on. Each atom has a set number of protons, and that never changes. So the number of atoms or number of protons in an atom never changes. What does change is the number of electrons. The number of electrons will either increase or decrease. And when you add electrons, you're going to add more of a negative charge to an atom. So it's going to cause that atom to become negatively charged. And that's what refers to as a negatively charged ion, or commonly referred to as an anion. Now, the other way it could go, if you lose electrons, you take away electrons. Now, you will have more protons than electrons. So you took away negative charges, which means that overall, you have more of a positive charge. Now, as you have more of a positive charge, you are going to be referred to as a cation. So a positively charged ion is a cation, a negatively charged ion is an anion. It's pretty advanced stuff, but I just want you to understand an ion in general, so sometimes we use the term ion just to refer to it, is just a positive or a negatively charged atom. All right, so I want you to understand that that means that they have gained or lost electrons, and they are now positively charged if they lost electrons, or they're negatively charged if they gained electrons. Now, how do we arrange elements? We arrange elements on the periodic table of the elements. So this is the periodic table of the elements. I'm sure you've seen it at some point in time. We are not going to get too advanced into this, but I want you to understand here is one of our key elements: hydrogen, carbon, nitrogen, oxygen. Those are like the big four of biology. And then we can also throw phosphorus in there, is incredibly important as well. So those 5 elements are going to make up the bulk of what we talk about this year. And carbon, hydrogen, oxygen are going to be the top 3 most important. All right. Now, last but certainly not least, what I want you guys to be able to do is be able to draw an element or an atom so that you understand it. So remember, we're going to have a nucleus. I'm just going to draw a large centralized nucleus. I'm even going to label it. And what particles are found inside the nucleus? Well, you have your positively charged particles, which are there called protons. And you're also going to have your neutral charged atoms, which are or particles called neutrons. Right? So that's what's in your nucleus. And then buzzing around the outside, that's where we're going to find our electrons. And remember, electrons, whoop, that's an S, that's not an E. I'll just cross that out. I know, I'm really bad at writing. Electrons are going to have a negative charge. Right? And the way I represent electrons is with an E minus. It's a more of an advanced scientific way to represent electrons, but that's an E minus. Now, I ask you, what element is this? If it only has one proton in the center and one electron buzzing around, that would be the element with an atomic number of 1, which equals hydrogen. And as we talk about more and more complex atoms, what really just starts to happen is they start to add more things to the center, and then they're going to start to add more electrons and more energy levels. So I know this is getting really, really messy, but the idea that you're just going to get more and more things built onto it. But if you understand the basics, that's all I'm asking you to do. And I appreciate you guys hanging out and learning a little bit of chemistry with me. Check out tonight. You got to do a little assignment, a little worksheet based on this kind of lecture. Shouldn't be too hard for you. Tomorrow, we're going to kind of build on what we know about chemistry right now, and we're going to talk about how atoms stick together and how they bond together to form compounds. So thanks for checking out everything's today, and I look forward to seeing you guys tomorrow. Bye-bye.